Okay, so we have to find the input impedance and then find the current I1. So first thing we're going to do is we're going to take care of the mutual inductance. So positive faces the direction of the direction of the red dot. Negative faces the other way. Value for this will be 5J, the mutual inductance value, times whatever is entering this port. So we see it's minus I2. And then for this one, it's also 5J times whatever entering this port, which will be I1. Now, to find input impedance, we're going to treat this as V instead of 50 phase or 60 degrees, because input impedance is equal to V over I1. So we're going to do mesh I1. So it's going to be minus V plus Z1, which is 60 minus 100J I1 plus 20J I1 minus 5J I2. So let's bring the V to the other side. So V will equal all of this. Now what we have to do is do mesh I2. So it's going to be minus 5J I1 plus 40J I2 plus Z2, which is 30 plus 40J I2 plus ZL, which is 80 plus 60J I2. So let's combine all the like terms inside here. So we see we can combine this and this. So that's 110. And then we can combine this, this, and this. So that's 140. Okay? And now we'll isolate for I2. So it's going to be 5J all over 110 plus 140J I1, and that's equal to I2. And we're going to put I2 into here. So V is equal to 60 minus 100J I1 plus 20J I1. Let's first combine these two. So it'll be 60 minus 80J. And then we have I1 sit in the bottom. Sorry, so I1 sit outside here. Minus 5J. And we just incorporate the large equation out here. 5J all over 110 plus 140J I2. Sorry, I1. Well, let's see what we can do next. We can distribute this into here. So minus 5J times 5J, that's plus 25. Okay, so that's good. What else? I think, okay, so we can times this side by 110 plus 140J. So it'll be the following. And that way we can add to this one, okay? And remember, this is I1 here. So then we will just add 25 I1 here as well. So next thing we're gonna do is we have to add all of this together. So we're gonna distribute everything. So 110 times 60. Let me see what that gives me. 110 times 60. That's 6,600. Then minus 80J times 110. That's minus 8,800J. Then 140J times minus 80J. That's 100. Oh, sorry, 11,200. And then the last one is 84 8,400 J. Oh yeah, and then plus 25 at the end. Okay. And now what we're going to do is collect like terms. So this turns into, the top turns into 100. Oh yeah, then there's I1 at the end as well. So it's 1,780, what was, sorry, 17,825 minus 400J all over 110 plus 140J. Convert these into phasor format. I keep forgetting the I1. And remember, this is all equal to V. So in phasor format, it's 17,829 phasor minus 1.286 all over 178.05 phasor 51.842. So V will be, so this divided by this gives you 100 phasor, and then this minus this is minus 53.128, and obviously times by I1. Now, Z input is equal to V over I1. So we're just going to put 100 phasor minus 53.128 I1 here, and this cancels out with the bottom I1. So this is actually our answer. So our Z input, or impedance input, is 100 phasor minus 53.128 degrees. Okay, now the second part asks to find I. We know what V was. V was 50 phasor 60 degrees. So it's going to be 50 phasor 60 degrees all over 100 phasor minus 53.128. That gives you I1. So that's 1 over 2 phasor 113.1 degrees, and this is in amperes.